Okay, hi guys, welcome back to the November 2023 AAHL paper 1, and this is question number 9. So, first part is part A, and it says show that f is an even function. So, all this means is that there's two outcomes that you can do. So, the even function and odd function. Basically, what even function is this: f of minus x should equal to f of x, and this means that it's even. Okay, and then odd just means f of minus x should equal to minus f of x, which is meaning that it's odd, that's all. So now all we have to do is, since we are given that it is supposed to be an even function, we have to prove it like this. So uh, we just have to plug in the minus x. So f of minus x will be equal to sine square of minus kx because of the minus x divided by minus x whole square, which will be equal to, now you can write minus sine kx whole square, divide that all by our x square. Now this becomes sine square of kx upon x square, right? Now this will be equal to f of x. That's it. That's all for part A. It's that simple. So this is how we do part A for these type of questions. And now I'll explain how to do part B. So part B is the 6 marker question. So this is a little bit longer, but yeah, it's a good type of exercise and question to do. So yeah, we can get started on this question now. So first question we do is that we're given that limit x tends to 0 of f of x is equal to 16. So next step may we can put the f of x into this. So limit x tends to 0 sine square of kx divided by x square is equal to 16, right? So we have that. Now, if I want to find the value of k, so first let me put the 0. So, but this becomes sine square 0 upon 0 square. Now, in limits, if you have something like this, see, this will equal 0 upon 0, right? This is called a, what we call the indeterminate form. So you can just write like NA. So indeterminate form is not valid, so we have to use a rule called L'Hospital. So it's called L'Hospital's rule, and this rule basically allows us to break the laws of differentiation. That's how I like to think of it, because in this really how when we differentiate we have to use quotient rule, right? But in L'Hospital's rule we can just differentiate the numerator and differentiate the denominator. So separately, no need for quotient rule, you can directly do it as many times as you can until you get out of the indeterminate form essentially. Okay, so now I will do that and write it. So um, sine square of kx. So first of all, let's take the derivative. So we can rewrite this as sine of kx whole square. Now this will just bring the, you have to use chain rules obviously. So this will become the dy by dx of this will be 2k, and then sine of kx obviously, and then this will be also the inside portion. You have to take the derivative since we are doing the chain rule, right? So what is sine k of x derivative? It is cos kx, right? Now the denominator derivative is going to be simple 2x, uh, and I'll be making a lot more derivative and integral videos so for the JE course, so you can see how we do the steps as well. But I mean, for the steps for this, you can just, you bring out the 2 and you have 2 sine of kx, and you have 2 minus 1, which is 2 sine of kx raised to 1. And since we have a k over here, we need to differentiate this also, basically the 3x, or if it's a 3x or a kx. What is that? So kx. So this will become the constant only is remaining. So the k also comes in this case. Okay. So this is quite simple differentiation. And now if I am going to put the 0 into this equation, let's see what happens. 2k sine of 0 cos of 0 upon 0. So this is again indeterminate form. So now we need to use L-Hospital rule again, right? Because now we get to remember I kept saying we have to keep on doing this rule until we get out of the indeterminate form. So now this kind of derivative of the numerator is kind of difficult, but you can use the product rule and do it, but it'll take a little bit more time. But rather what I would like to implement for you guys is very simple technique, which is, if you heard of the or learned about the double angle identities, you can make out that you can see one over here. So double angle identity, man. You can see that sine 2 theta. This is a very famous one. Sine 2 theta is equal to 2 sine theta cos theta, right? So we have to use this angle identity. Now in JE, you have to memorize all of this. But in IB board, this is given in the formula booklet, I believe. But if it's not, then just memorize this. There's also cos 2 theta. It's equal to cos square theta minus sine square theta, which is also equal to 2 cos square theta minus 1. This is also equal to the famous one, which is 1 minus 2 sine square of theta. So just take note of these. But for now, all we need to worry about is the sine 2 theta, which is equal to 2 sine theta cos theta, right? So all we have to do now is implement this. And we just have to modify it a little bit since we have 2k sine of kx into cos of kx. So all this is the internal portion of the sine 2 theta is just sine 2kx and into k. So essentially we have this as now, we can write it as k sine of 2kx, right? We can write this as that, right? They're both interchangeable upon 2x. This is a better derivative to take. So let me just add a page since we don't have enough space. So now can take the derivative of this now. So k sine of 2x. So this we have the k constant and then we have sine of 2kx, right? So sine of 2kx will be equal to, we have it as, we can bring out the k. So we have, now we have to bring out the 2k because it's already a constant is there. So 2k. So we have 2k squared now. And then we have the chain rule, which is the derivative of the sine of 2kx, which is simply cos of 2kx, right? And then what's the derivative of the denominator? It's just 2. So that's it. So 2k squared cos of 2kx upon 2, right? So now let's put the limit. So limit x tends to 0 of this one. I think this will work finally upon 2. So 2k squared cos of uh, 2 cos of 0. This is divided by 2. So this is 2k squared upon 2 is equal to k squared. So we know that k squared is equal to, we are given it's equal to 16. So 16. And we get two solutions, which is k is equal to plus or minus 4. But we are given here that it should be this within this domain, right? So that means that our negative solution is not an answer. So k is equal to only 4. That's it. So that's how you do this type of question. And if you guys have any questions for this type of question, just leave it in the comment box and I will respond immediately. And yeah, that's all. So if you have any other questions, do let me know. And please do just subscribe and please do like and share this video. So thank you guys for listening and understanding. Thanks.